activities. In particular, OEM, ODM, and OBM. Okay, these are the commonly practiced modes of manufacturing in the manufacturing industry. Yeah. And we also have introduced the S-curve of TVs. Yeah, what is S-curve? Technology S-curve. We have used some examples such as the display technology, the display technology, and the illumination technology, to showcase the S-curve in technology evolution. Technology evolution S-curve. And the lead, we also talked about the lead of a product development process. Why we need to have a product development process? Because it provides us 5 basic functions. It provides the product development process provides us 5 basic functions. If we have the 5 functions in a product development process, then we may be in a better control. The guide, monitor, communicate, control, and document. These are the 5. And a sample product development process. Actually, this is just a sample, but in some textbook they show just 4. They condense to 4, or some expand to 6. Okay. Nevertheless, in our course we use 5. Okay. There are some minor variation. And the product validation. In the product validation stage, we have to use some prototypes. We can use alpha prototype at a certain stage, and use beta prototype in some stage. So if you are in product development, normally you should understand what is alpha prototype or what is beta prototype. Okay, just some terms. Now we introduce 5 basic rules of quality function deployment. So for the quality function deployment, we only need to know the 5 rules. What are the 5 rules? The first one is the customer requirement. We need to know what is customer requirement for a particular product, right? For example, if you are designing a pencil, what might be the customer requirement for a pencil? Write clearly, write consistently. Consistently, let me see. What is consistent? You can think about. So what kind of customer requirement you can think about? Okay. So here, customer requirement priority. So benchmark. So here, if I ask you to do a QFT of a product, you just need to show the procedures, okay, as to what kind of marks a particular product customer or particular brand may score. I don't care. So if you are doing this one, you need at least have 3 brands. Okay, you can use ABC. And for each of the customer requirement, a brand may score a mark. Normally a scale between 1 to 3. So how to assign a mark for a particular brand? I don't care. Okay, I only look at whether you have assigned a mark for a particular customer requirement. As to 1, 2, 3, 4, 5, I don't care. Okay, I just look at your procedure, whether the procedure is correct or not, because you are not an expert. Maybe you are not an expert in designing the product. Yeah, if you are actually engaged in designing the product, you might give better values, but I do not assess that aspect. Okay, that's the customer requirement priority in terms of a scale 1 to 5, for example. So normally here, I want to say 3 brands. 3 brands. And then here, this room is a technical product specification. These specifications are listed in columns. In columns. And then again, like the customer requirement, you need to give each of the brand a score in the technical spec, in each of the technical spec. So also 3 brands. I need to as to you may have a scale of 1 to 5. 1 to 5. So as I said, as for this, I don't care what score you give to a particular brand. Any score will be okay as long as you give a score. You show this 3 brand here, show 3 brand here, that will be okay. The scores may be random, it's okay, it's up to you. Okay, I do not assess the scores you have given. Okay, that's a KFD. If you are doing a KFD, you need to, you know what I expect. Okay. Now, design failure mode and effect analysis. We need to know the concept. What is a design failure mode and effect analysis? What does it do? What does it do? And how to do it? Here is a roadmap. The roadmap help us to do it. Help us to do the design failure mode and effect analysis. So after you have done this, follow the roadmap. The final results. This is the final results. It's a form. Okay. This is the final result in terms of a form. And these are in the form, these are the basic information we must provide. We must provide. The first column is a function. Maybe in some design we look at only one function, for example, one function. Because normally in our course we only use very simple designs. For example, design of a pencil, design of a clothespin, design of a fingernail clipper, whatever. Those are very simple. Potential failure modes. You need to figure out potential effect of the failure. And this value severity, you again, here you need to assign a value. I do not assess whether the value assigned is correct or not. You need to assign a value. Okay. Assign a value, a potential cause of the failure. Assign a value. Occurrence. Current control of this value detection. And the final one, RPM. Okay. So these values are assigned by you. So I will not, as I said, I will not assess whether the value you assign is correct or not, or reasonable or not. I don't care. Okay. I just look at whether you can follow the procedures in doing a design failure mode and effect analysis or not, and the corrective action priority, etc. Okay. Lastly, the treats, problem solution concept, and the process. For this one, the treat method, we have 39 engineering parameters and the 40 inventive principles. Okay, they are correlated by the contradiction matrix. This is the contradiction matrix. We can use this one to correlate the engineering parameters and the inventive principles. we can list the 39 engineering parameters as a matrix, 39 rows and 39 columns. Yeah, for particular row and a particular column, we have an intersection. And the intersection is a solution. Yeah, some possible inventive principles. So in our course, my requirement is about 5 inventive principles. Yeah, altogether we have 40 inventive principles, but I only require you to understand five inventive principles. Right? 5. Which 5? Up to you. You can choose a 5 which is the easiest for you to understand. Okay, for example, segmentation is easy, right? So which 5? I don't care. Okay, 5. And the 3 sample design for each of the inventive principles. You may, say, for example, in my PPT file, uploaded, for each of the inventive principles, I have provided some examples. If you think those examples are not very good, you may search from the internet. I believe there are a lot of materials you can get from the internet. Okay. So you know which 5 inventive principle? Up to you. Okay, up to you. Now we come to the 3D modeling. 3D modeling, what are the popular solid modeling schemes? We have in our course, we mainly focus on parametric models. Parametric models. For parametric models, we have explicit, inexplicit parameters, constraints. And we need to know how to, what is an evaluated parametric model. For evaluated parametric model, they must have all the vertex defined. We have the x, y, z coordinates for each of the coordinates. Basically, the evaluated model is a surface model, it's a boundary model. The evaluated model should be a boundary representation model. For boundary representation model, you have all the edges, right? Now, sweep representation, we also spend a fair amount of time on sweep representation. For example, surface of revolution, solid of revolution. If it's a curve, when we revolve, then you have a surface. If it's a surface, then you revolve, get a solid. We need to distinguish between surface and the solid. Surface has low volume, solid has volume. Okay, and the sweep surface, sweep volume. Normally we define a profile, open profile, closed profile, and a sweeping path or axis of revolution. So what is invalid and valid? Okay, you need to understand valid and invalid. Now, solid modeling, we look at constructive solid geometry, binary trees, and the BREP mainly look at wind edge data structure. It is a common structure for boundary representation. Now we have design feature-based technology. Mainly we will look at automatic feature recognition based on AAG. This graph and the problems of the AAG methods. As for additive manufacturing, we focus on the 6 process. We focus on the 6 process. We need to understand what are the principles for each of the process. And the STL file format. STL file format in text format. In text format, we know that we have 7 lines. 7 lines for a triangle. 7 lines for a triangle. What are the 7 lines for the triangle? And how about the graphic form of a STL file? Graphic form of the STL file, we should have many triangles and many unit surface normals. Very spiky, like a cactus. That's the graphic form. And the base triangulation given a polygon or a point set. So what is the best triangulation? We have mentioned about that. Maximize the minimum angle in the triangulation. So which one will guarantee that we get the best triangulation? We have introduced the Delaunay triangulation. What is a Delaunay triangulation? I have introduced, right? So how to get the detailed computation part? We don't care. We know that this one, Delaunay triangulation, is from a diagram. What is the diagram? Morano diagram, right? In the Morano diagram, then we just connect the points in the labeling cells. If a point has many labeling cells, then we have to connect that point to all the points in its labeling cells. Then you get the Delaunay triangulation. And the Delaunay triangulation guarantees that the best triangulation for a set of points is got. So as to the mathematical computation, we don't need to worry about that because somebody have done that for us already. We only need to know that this will give us the best triangulation. Major problems of STL file format I have pointed out in today's lecture. And the existing alternatives to STL file format, I have pointed out. At least you need to know 2 of them. The name, ANF, OBJ, for example. No detail about alternatives are needed. But we need to know why we need to have the alternatives. Why? This one. We need to know the reason why we need to have the alternatives for STL. I have explained mainly in terms of material, color, surface texture. Basically, if you know the problems of STL file, then you know why we need to have alternatives, right? And the SLC contour file of layers. And the part accuracy problem in additive manufacturing. For this one, we have computation related. For process related, we mainly focus on part build orientation. And for material related, we looked at curve distortion. And then we have introduced the application, sample application of 3D printing. For example, direct shell production casting. Using casting, metal casting. And another one is indirect shell production casting. Okay, so that's about all the outline of the course. I hope that you have good knowledge in your exam. Thank you very much. If you have any questions, you may always approach me or in my office or by writing me an email. Okay, thank you very much. Thank you.